Hi everyone, welcome back to Innoskrit, and in this video I'm going to discuss the Capgemini pseudocode. So this video actually consists of all the questions that have been appeared on 16th August 2021 in Capgemini pseudocode exam. That is the round 1, I think, right? So I have processed all those questions from somewhere, right? And I'll be discussing those questions in this video only. See, right? So this video is actually going to act as like a mock test for Capgemini, right? Right, so let's get started with the very first question. So evaluate the given postfix expression. So whenever we are given the postfix expression, we need to do this using stacks, right? Using stack. Okay, so what we do is actually, so let's suppose whatever expression is given to me. So I'm going to fetch the character. So let's suppose if that character is an operand, then I'm going to push that into the stack. And if that character is an operator, then I will perform some operation. So let's see how I am going to do that. So let's suppose this is my stack. And now I am going to process this given string. So now because the first character is an operand, so I am going to push that into the stack. Now second character is actually again an operand, so I am going to push that into the stack. Now third one is the plus sign, right? So whenever an operator will come up, or whenever an operator will appear, so I am going to push two values out of this stack and I am going to perform the operation on that. So what I'll do is I will pop 2 and I will pop 1 and I am going to perform this operation something like this. So this is going to be 3, and whatever value I will get, I will again push that onto this stack. So now the updated value in this stack will be 3, right? Now let's fetch this one. So again 3, because 3 is an operand, so I'm going to push that into the stack. Now next is operator. So whenever operator comes, I'm going to pop out from the stack and I'm going to perform this operation. So the value this time is 9. So 9 will be pushed back onto the stack. Now next value is 4. So 4 will be pushed into the stack. 2 will be pushed into the stack minus. So whenever an operator comes, so I am going to pop two values. Now you don't have to be confused with it. So the first value which will be popped will be actually the second value, and the second value which will be popped, that will be the actually first value. So you really don't have to be confused with it. But I'm repeating once again, the first value that will be popped is actually the second value, and the second value which is actually popped is actually the first value. Now you are going to perform this operation here. Now you will get 2. Now this 2 will be again pushed back into the stack. Fine. Now next is 3. So 3 will be pushed. Next is 1. 1 will be pushed. Now the next operator is plus. So whenever plus comes, or whenever an operator comes, we are going to pop two values. So 1 and 3, something like this. And we are going to perform this operator. So 3 plus 1 is actually 4. Now this 4 will be pushed back onto this stack. It will appear here. And now next is multiply. So I'll again pop two values. So 4 will be popped, 2 will be popped. So 4 will be popped, 2 will be popped, and I'm going to perform this multiplication. So this is going to be 8, right? Now 8 will be again pushed back onto the stack, and now next operator is minus. So I will again pop two values, 8 and then 9. So 8 will come here and 9 will come here, and I'm going to perform this minus, and this will be 1. So the answer is going to be 1. So I hope this makes sense, right? So answer will be 1. So I think this is clear. Now this second question is again to actually evaluate the given postfix expression, but I would recommend you guys to solve this problem and comment down the answer. So this is actually the homework problem for you guys, right? So now let's move to the third question. So these are the questions from exactly Capgemini exam. Yes, so it was easy. That was not really tough. That was easy, very easy, right? Fine. So in this question, a tree is given and we have to identify the in-order traversal. Now in-order traversal is very easy. I think in the very first or second video, I taught you how to calculate pre-order, in-order, and if you don't really know, then you can watch my binary tree playlist, and in that playlist, I think the second and third video is actually based on in-order, pre-order and post-order. So you can definitely watch that, right? And I have processed some very easy trick in which you can find out the answer in within 30 seconds, all the traversals, right? Great. So that means the answer to this question is nothing but in order. Whenever in order is given, so in order is actually exploding. First we go to the left, then we print the data, and then we go to the right. So left, left, so extreme left is D, then after that this is B, because to process B first we will have to go to the left, and then we will print B, and then we will go to the right. See this one, then D, after that B, then B, then E. Now because left of A is completely processed, now we can process A. Now C, but before C we have to go to the F, so F and then C. So this is going to be the answer, D, B, E and AFC. So I think answer A is the correct option, right? Now let's move to the next question. So which of the data structures can have more than one logical way of traversing? Now see, array can be processed using for loop. Now because array can be processed using for loop and while loop, it doesn't mean that it is having more than one logical way of traversing, right? So that is really not the case. Similarly, you can think about this also, because linked list can be traversed using do while and while loop also. So that doesn't mean that this is going to be traversed in more than one logical way. Logical way, we are talking about logical way. So the logic is same. If I am saying that I am going to traverse this array using for loop and then while loop, the logic is same. The logic is not different. The logic is we are traversing it using loop. That's the logic. So in this question it is asking which of the data structure is having actually more than one logical way of traversing. So that means I think this is tree, because tree can be processed using BFS, using pre-order, using in order, and using your post order. So this tree is actually having multiple ways of traversing. I hope this makes sense, right? So the answer to this question is going to be tree. So let's move to the next question. I'm repeating once again, the paper was very easy. Yeah, the paper was very easy. Okay, fine. So now if you are using bubble sort to sort the given numbers in ascending order, so this is the order of the number which is given to us, then it is asking actually to find out the minimum number of swaps required. That means that when this array will become sorted, at the moment whatever be the number of swaps will be, that will be our answer. So let's try to first write the original array. So 10, 7, 5, 8 and 9. So that is the very first situation. So at this moment we do not have any number of swaps. So now let's try to perform the very first swap. So in the very first swap, this 10 and 7 will be swapped. So 7 will come here, 10 will come here, otherwise all the array will remain same. Fine. In the next step, this 7 will remain here, this 5 and 10 will be swapped, and rest of the array will remain same. In the next step, this 7 and 5 is going to remain same, this 8 and 10 will be swapped, and then 9 will remain same. In the next step, 7, 5 and 8 is going to remain same, this 9 and 10 will be swapped, so this will come here. Now this is actually the one pass. Why this is one pass? Because in one pass the largest element of this array is actually at the end of this array. Fine. Now is this array sorted? No, this array is not actually sorted, so I am going to perform more operations, right? Now I will have to check with this one. Is 7 and 5? Yes, 7 and 5 should be swapped, so this will be 5, 7. Then let's suppose rest of the array is same. Now do we really need to further swap any values in this array? No, right? So this is actually the second pass, and in the second pass this array is sorted. So what are the minimum number of swaps to just sort this given numbers, the set of given numbers? So this is 1, 2, 3, 4 and 5. I hope this makes sense. So answer is 5. Yes. Now let's move to the next question. So the question number 6 says that find out the array representation of the given min heap if the value 25 is inserted in it. So let's try to understand this. So most of you will think about that this is the answer. D option is the answer, because this is actually forming the min heap. क्योंकि आपको लग रहा होगा 10, 25, 10, then 15, then 25, then 40. So it will actually seem to be the correct answer, but that's really not the case. So I'll have to tell you something. So let's suppose first of all try to make the heap out of this given array. So this is the sequence of array which is given to us, right? So according to this sequence I will have to create my heap first, that is the min heap. So this is 10, 15 will come here, 30 will come here, 40 will come here, 50 will come here, 100 will come here. Yes, this is the heap. This is actually our heap. Now you must have read this concept that whenever we try to insert any new element into the heap, that will always be inserted at the last of the last empty position. I am repeating it once again. Whenever you are trying to insert any new element into your heap, whether it's be min heap or max heap, it really doesn't matter that in which of the heap you are trying to insert the array. The concept is that whenever you insert any new element into your heap, the element is always added at the last empty position, and the last emptied position in this situation is going to be this one, the right of the 30. I hope this makes sense first of all. So now 25 is inserted at the right of the 30. Now I need to check whether this formed heap is actually the min heap or not, right? So when I will try to fetch out this situation, so I will see that no, this is not going to be your min heap, because 25, the insertion of 25 is actually creating a problem, right? Insertion of this 25 in here is actually creating a problem. It is not going to be min heap more, right? So what I'll have to do is I will have to heapify it, and when I am saying that I have to heapify it, I am trying to say that it has to be checked with its parent, whether the parent of 25 is lesser than 25 or greater. If it is greater, then swap it. So that means that 25 and 30 is actually going to be swapped. So this 25 will come here and this 30 will come here. So that means this 25 will come here and this 30 will come here. So now is it a min heap? Is it a min heap? Yes, this is a min heap, because 10 is the parent of 15 and 20, and 15 and 20 both are greater than the 10. Or you can say that the parent of 15 and 25 is actually smaller than both. And you can actually see this one at every node, right? So this is fulfilling the property of min heap now. So what is the array representation of this heap? 10, 15, 25, 10, 15, 25, then 40 and 50, then 40, then 50, and then 100, and then 100, and then 30. So that means 10, 15, 25, 40, 50, 100, 30. So option B is actually going to be the answer, right? So I hope this makes sense. तो गलत मत करना यार, ठीक है? Fine, चल, great. So let's move to the next question. Now, which of the following is not an array representation of max heap? Right. So this kind of question can also be given. So what we have to do in this kind of question is that we will be creating the heap, max heap of all the given situations, all the given arrays, all the given set of numbers. So let's try to create the very first one. So 31, 27, 23, then this is going to be 17, then this is going to be 13, and this is going to be 11. I think this is max heap. This is forming max heap. The parent of 11 is greater, the parent of 13 and 17 is greater, the parent of 27 and 23 is greater. Yes, this is max heap. So this is fulfilling the max heap. Now let's try to the second one. So 10, 5, 3, 2, and 4. Yes, I think this is also creating the max heap. The parent of 5 and 3 is greater, the parent of 2 and 4 is greater. Yes. Now let's try with the third one. So 12, 15, oops. The parent of 15 and 17 is smaller. So this is not going to be the max heap, right? So that means only the option number 3, that is the only statement number 3 is not actually the array representation of max heap. Otherwise 1 and 2 are the array representation of the max heap. So I hope this is clear, right? So the answer to this question is going to be only 3. I hope this is clear. Fine. Now let's move to the next question. Now, so what is the output of the following pseudocode? So we will be doing actually this question very carefully. So A is 7. I am telling you the way that you have to perform this question, right? A is 7, B is 7, and C is 4. Now the array is actually iterating from 4 to 7. So C is equals to 4, C is equals to 5, C is equals to 6, and then C is equals to 7. That is how you have to do the question, because otherwise it will be wrong. Fine. Now 3 variables are updating: B, B and A, B, B and A, B, B and A, and here also B, B and A. So from 4 to 7 I have to perform these things. Now B, how B will be updated? 2 plus A. What is A? 7. So B will be 9. B will be 9. 2 plus A, B will be 9. So this updated value I will be writing here. At each moment I will be writing the updated value in here. Fine. In the next step, B is equal to B plus 11 plus C. What is B? 9. 9 plus 11, updated value of B is 9. 9 plus 11 plus C. What is C? C is 4. So this is going to be 24. That means B is going to be updated again 24. Right? So each time we will be picking the updated value from here only, right? Now next, in the next step, A is getting updated. So A is actually 8 plus 4 plus A. 8 plus 4 plus A is 7. So 12 plus 7 is going to be 19. So A is 19. So this is the iteration number 1. Similarly, in the next step, we will be finding out the values. So that means the value of A, B and C at the last moment are these one. Okay, now we have ended up with the for loop, and again we are doing some changes in A. So this A will actually become 4 plus A. And what is A? A is 55, so it will become 59. So final the value of A is 59, B is 45, sorry, B is 63 and C is 7. So now we have to return the answer of A plus B. So that means 59 plus 63 हमें return करना है. So 59 plus 63. So no, 9 and 3 will be 12. So 5 and 6, 6 and 6, 122. So the answer is going to be 122. I hope this makes sense. So 122 will be the answer. So this was not actually tough, but it was time taking. So that means that in some questions you have to do some questions in just by reading the questions, and in some questions you have to really focus and you will have to give some time, right? Fine. So now let's move to the next question. See this one. So there are some values, integer p, q, r. So p is set to 0, q is set to 10 and r is set to 7. So p is actually 0, q is actually 10, r is set to 7. So now there is some if else. So r plus q minus p, that means r plus q means 17 minus 0, 17. Okay, I have to check this one by this one, p plus r. So what is p? 0. R, what is r? 7. So that means 7. So 17 is greater than 7. Yes, condition is true. If condition is true, that means this will be evaluated. So what is saying? R is equals to p and p. What is p? 0. 0 and 0. So r will also become 0. Now the updated value of r is 0, q is 10 and p is 0. And we have to return the answer p plus q plus r. So 0 plus 10 plus 0 is actually going to be 10. I hope this is clear. So the answer will be 10. Fine. So now next question is again exactly same as I have done in the question number 8. So I would recommend you guys to solve this problem, solve this question and comment down the answer. I will tell you whether it is correct or wrong, right? Now let's move to the next question. So this is very easy. So we have three traversals. In tree we have three traversal. The first one is in order, the second one is pre-order, and the third one is post order, right? So I'm just telling you one thing. In order, first of all, left will always be to the left of right. That is one thing that you have to keep in mind. Left will always appear then before the right. Left will always appear before R. Fine. Now in order, D will be in between of L and R. In pre-order, D will be to the extreme left of L and R. And in post order, D will be at the end of L and R. That's the only thing. So in all the three cases, L is actually left to the R. You can observe it from here. L is always left to the R. And I have inserted D as per the in means between, pre means at very first, post means at the very last. That's the only thing. So now you can fetch out the answer from this thing. So they are actually representing D means data by root. So we have to fetch the answer for pre-order means first root, then left, and then R means right. So root, left, right. Okay. So option number C will be the correct answer. Now let's move to the next question. Okay. So one thing that Capgemini have done is actually very good, because means if they have used some continue statement at somewhere, then they have explained what is continue. Similarly, if they have used this exclusive OR operator, bitwise OR operator, then they have explained it in a very correct way, so that you don't get any confusion, right? So let's try to do this question. So this is actually the function which is actually accepting three values, a, b and c, and the values of a and b and c are given to you. Fine, now you have to do some calculation and you have to process your answer. So what is a? First of all, a is 3. A is 3. So what is the binary of a? Binary of a is actually 0, 0, 1 and 1, because 1, 2, 4, 8, this is how this goes on. So the somewhere 3 will be formed, we are going to set those bits. So 0, 0, 1, 1, so because 2 and 1 is going to make 3, so 1, 1 I will set these, something like this, right? Now next is 8. So 8, the binary, the bit of 8 is, you see, exactly below the 8 you are going to set it as 1, otherwise everything will be 0. So this will make 8. Means you have to set all those bits only through which you can create the sum as 8. So because just by using this 8 wala bit, you can make the complete it as 8. So that's why you have set this 8 bit as 1, otherwise everything is 0. Okay, fine. So that means you have processed this one. Now, what will be the OR, bitwise OR of these things? So 1, 0 will be 1, 0, 0 will be 0, 1, 0 will be 1 and 1, 0 will be 1. You can read this one. So it is saying that if the first operand to the, you have to compare the operand of corresponding first and second operand. If one bit is 0 and other bit is 1, if one is 0 and other one is 1, the corresponding result is set to 1, otherwise it will be 0. I hope this makes sense. Fine. So that means the answer would be this one. The evaluation of this thing is will be 1, 0, 1, 1. Now what is going to be this one? So 8, 2 and 1, that means 11. So that means 11 is less than 8 is actually being checked in this if condition. So is it true? 11 is less than 8. Is it true? No, this is false. This is false. And because this is false, so this is actually not going to be processed. So that means this if is not going to be processed, and we are going to directly return a plus b plus c, right? Okay, so that means this if is not going to be evaluated. So what will be a plus b plus c? The given actually a plus b plus c. So what is that? 3 plus 8 plus 7. So 8 and 3 will be 11. 11 plus 7 is equals to 18. So the answer is going to be 18 in this case. I hope this is clear. So answer will be 18. That was very simple. If let's suppose if this condition would have been made it as true, right? So you could have processed these two also. Then these would have created the changed the value of c also. Then you must have been using the updated value of c here. I hope this is clear. Fine, great. Now let's move to the next question. So the next question is something interesting. So you have to look at this very carefully. So we are given a as 3, b as 7 and c as 9. And now you are checking whether 6 is less than c. 6 is less than c. What is c? C is 9. So condition is true. Condition is true means this is going to be evaluated. What is this? C is actually getting updated by 5 bitwise OR 1, then the bitwise OR of this with C. Okay, now, so first of all we are going to bitwise OR these two. So what is 5? 5 is actually 0, 1, 0, 1. What is 1? 1 is actually 0, 0, 0, 1. So the OR of these will be 1, 1, 0, 0, 0 will be 0, 1, 0 will be 1 and 0, 0 will be 0. So this is actually going to be 4. Fine. That means now the updated step is 4 will be bitwise XOR with C. And what is C? C is actually 9. C is actually 9. C is actually 9. Right? And whatever this value will be updated, that will be updated into C. So let's try to do this. So the bit 4 is actually this one. The bit 9 is actually this one. What will be 9? 1, 0, 0, 1. This will be 9. So 0, 1, 1, 0, 0, 0, 1, 0, 1 and 0, 1 is 1. So this is actually going to be 13 because 8, 4 and 1. So 8, 4, 12 and 12, 1 is 13. So that means C will be storing 13. The updated value as 13. So that means that in this if condition, the C has changed from 9 to 13. and at the last you have to return the answer of these sum of these three. So 7 plus 3 will be 10, and then 10 plus 13 will be 23. So that means the answer to this question is going to be 23. I hope this makes sense. Now let's look at the last question. So the last question here, we are given a graph, and in this graph it is actually asking the topological ordering. So it is saying that you are given a directed graph, and using this directed graph you have to find out the topological ordering if it is possible, right? So, and if it is possible, then how many number of orderings will be possible? So let me tell you, for a given graph you can have multiple topological orderings also, right? So if you don't know about topological ordering or how to calculate topological ordering, you please let me know. I will try to record one video for you. In that case, if you don't know, right? Otherwise, if you know, then you must be knowing that topological ordering can be calculated for those graphs only which does not contain any cycle. This is the very important. So that is why topological ordering is always performed on this kind of graph. And what is DAG? DAG means directed acyclic graph. So directed means that graph should be directed. Acyclic means that there should be no cycle in the graph, and graph is graph, you know, right? So topological ordering can always be calculated on this kind of graph only, but we will have to look very carefully whether this graph is actually kind of DAG graph or not. So that means whether this graph is directed, yes, this is directed, we can see these directions definitely. Whether this graph is acyclic, that is very important. So if you look at this thing, अगर आप इस चीज पे देखते हो, just look at this one. So this particular part is not actually acyclic. So this is cyclic. From U, you are jumping to S, from S you are jumping to T, and from T you are jumping to U, and then from U you are jumping to S, and you will run up into the cycle, right? Look at it very carefully. So this is not acyclic, this is forming cycle, right? So that is why, because this is forming cycle, so we cannot have any topological ordering for this graph. So the answer to this kind of question is going to be no topological ordering is possible. So I hope you have enjoyed the video, and this is what we can expect in Capgemini pseudocode questions, right? So these are the exact questions that I have taken from Capgemini screenshots. Okay? So there are few students who I am associated with, right? And from those students I have calculated this data and these screenshots, and then I am finally making you prepared finally for Capgemini, and I am giving you the last hit to crack Capgemini exam, right? So just go through these questions, practice, and all the very best. I think this is the last video on Capgemini, and wish you all the very best. Thank you. Bye bye for now.